Good everyone, today we'll be looking on projectile motion. Now before we talk about projectile motion, we have to throw more light on what is a projectile. A projectile is an object or a body which is launched into space to move freely under the action of gravity. Examples of such body is a javelin. Now the javelin is now known as a projectile. Now the javelin is allowed to move freely under the action of gravity. Now such motion has two independent planes. Number one is the vertical plane and the horizontal plane. Now the vertical motion which has a constant acceleration, but the velocity changes uniformly, and the horizontal motion which has a constant velocity. Now the acceleration due to gravity is zero on this plane, and the path the projectile take is trajectory. Now as you can see in this graph, there's a curve. Now this curve is also known as a parabolic curve. The path out which a projectile take is called a parabolic path. Now before we talk about projectile motion, there are three things to consider, or let me just say more than three to consider. Number one is the time taken, which is small t, and the capital big T, which is time of flight, and range with the maximum height. Now if a body is launched into the air, the initial velocity is zero when it approaches maximum height. Now the time taken is the time to reach the maximum height. The time taken is different from the time of flight. The time of flight, this is the time taken from the projectile to reach the maximum height and then return to the plane of projection. The time of flight is also the time taken to cover the range. The time of flight is also the time taken to cover the range. The time of flight is also the time taken from the projectile from the point of launch to the point at which it hits the projection plane again. Now the maximum height, this is the highest vertical distance attained when measured from the horizontal. The range is the horizontal distance the projectile obtained from the point of projection to the place where it hits the projection plane again. Now all these are the concepts of a projectile motion. The angle of projection is the angle between the horizontal and the vertical plane of the projectile. Now, like we said, the projectile motion has two independent motions. Number one is the vertical component, and the other one is the horizontal component. The vertical component, which is like this, and the horizontal component. Now the vertical component is u sine theta, while the horizontal component is u cos theta. Now you can obtain this equation, which is the time taken, from the equations of motion. Now since you know v is equals to u plus or minus gt, so anywhere you see u, since we are dealing with the vertical component that acts against gravity or that has an influence with gravity, we need to use this u sine theta. Now we'll replace u as u sub y. Now u sub y is equals to u sine theta. So anywhere you see u sub y, you put u sine theta. V is equals to u sine theta minus gt. Now making t the subject of the formula, we obtain this equation from the time taken. Time taken is t is equals to u sine theta over g. Now since time taken is u sine theta over g, time of flight is capital T times 2t, and capital T equals to 2 times t. Now this small t here is the time taken. Time of flight is a big T. Now t, you know, is equals to u sine theta over g. This is t, u sine theta over g. But time of flight is equals to 2 times t, which 2 times u sine theta over g. So anywhere you see t, you replace it with u sine theta over g. Now these equations, these parameters are always used when solving projectile motion. The other one was the time taken. The time taken is t is equals to u sine theta over g. Time of flight is 2u is equals to sine theta over g. Now you take note of these equations because we are going to use them to solve questions relating to projectile motion. Now all these equations can be gotten from equations of motion. Maximum height is u square sine square theta over 2g. Maximum height is u square sine square theta over 2g. Take note of this formula because we are going to use them to solve the range. The range is given as, the formula to find the range is u square sine 2 theta over g. Now sine 2 theta, which is seen here, sine 2 theta is equals to 90 degree. Now sine theta is maximum at 90 degree. But making sine theta the subject of the formula, we find out that sine theta is the maximum range and is obtained at 45 degree. Sine theta is equals to 45 degree, and 45 degree is the maximum range. Now if you are told to find the maximum range, or you're told what is the maximum range of a projectile motion, the maximum range of a projectile motion is 45 degree. And it can also be said the maximum range is sine theta is equals to 90 degree. Now if we substitute 90 degree into this place now u square is equals to u square times sine 90, u square times sine 90 over g. Sine 90 is 1. U square times 1 will still give you u square. Now u square over g, which is this is the formula for maximum range, u square over g. Since sine 2 theta is equals to 90 degree, we just substitute. Anywhere you see sine 2 theta, we put 90 degree. 90 degree is equal to 1. U square times 1 is u square. U square over g. This is the formula to find maximum range. Now, we are given a question. Let's say a golf ball is hit at an angle of 30 degrees above the horizontal with a speed of 44 meters per second. Now, we should take g as 10 meters per second square. What is the maximum height? What is the range? Now, we draw down to solution. As we draw down to solution, we'll draw a graph showing the equations or showing the variables in the question. This is the vertical plane or the vertical motion of the projectile, and this is the horizontal motion of the projectile. Now this is the angle of projection. The angle of projection here, they say the angle of 30 degree above the horizontal with a speed. Now u is equals to 44 meter per second. Now g is 10 meter per second. What is the maximum height? What is the range? Now from the formula we know that maximum height is equals to u square sine square theta over 2g. So we are going to use that formula to solve for the maximum height. Range is u square sine theta over g. From the formula we are going to substitute the values, where u is 44, then sine theta is equals to 30 degree, then g is 10. U is 40. Now 44 square is equals to 1936. 44 square is 1936. Now 30 sine square 30 is equals to 0.25. 2 times 10 is equals to 20. Now 1936 times 0.25 divided by 20 will give H mass, the height is equals to 24.20 meter. Now, since we have gotten the height to be 24.20 meter, another one is to find the range. Now, what is the range? Remember the formula to look for range is r is equals to u square sine 2 theta over g, which is this one, u square sine 2 theta over g. Now we are going to implement that formula into here to solve the question II. We substitute the values. Now anywhere you see u, you put 44, which is what? 44 squared. Square sine 2 times 30 over 10. Now 44 square is you will have 1936. Exist. Now 2 times that will give you sine 60. divided by 10. Now, arrow 1936 times sine 60 divided by 10. What we have is array is equals to 167.66 meter.